So there is a base 12 version of pi that's different from what we know in base 10, and it emerges from this geometry right here. This is a diagram that perfectly divides a circle into 360 degrees using base 12 or Dawsonal math, Dawsonal geometry. It's a geometric pattern that's constructed on the base 12 Cartesian plane. So that's a Cartesian plane where the length of one is divided into twelfths instead of tenths. So this diagram is built in units of square root of 2. And precisely it's 0.5 root 2 is the precise length that is the sort of the smallest unit that we build all of these rings. We build polygons and then anchor the sections of diameter onto the points of the polygon. There's a little space between them, and that's what enables us to give or create this symmetrical pattern, perfectly symmetrical, perfectly balanced, everything's equal. And it's this ratio of the diameter and then a little space between them that gives us that ability, and the fact that all that geometry is anchored on the Cartesian plane. So we're using specific lattice points that don't exist on the base 10 Cartesian plane. They're not as precise points. When you're working in twelfths on the base 12 Cartesian plane, those are precise points that you can access and use to define the lengths of the radiuses of these circles. But in base 10, if you're trying to find points that are in twelfths, you can't really do it. You always have to divide by 10 first, and then you get repeating decimals. You try to get access to the points that are just super easy to access in base 12. So I've written a book about all this called Understanding Base 12 Math, How to Draw the Perfect Circle Using Dawsonal Geometry. That's what we're in the process of doing right here. First thing is to get the structure of that inner circle understood. Again, we're working in those units I was just telling you about. And it's the idea of the empty space. That's the really new idea. And it's just a realization that irrational numbers contain this little bit of extra space somehow. That's what makes it an irrational number, that it doesn't land precisely on the x-axis on a specific point. There's always a little gap in there. That's got really nothing to do with base 12, although the ratio is a base 12 ratio, but just the quality of an irrational number. And our model of that irrational number is a solid line with a little bit of a gap at the end that never closes. It never gets completely filled up. And so it's that gap that we're not dealing with. And actually, the correct model is a dotted line where that gap is dispersed throughout the line. So that's what's happening here. There's a space between all those black points of the diameter. And that's what gives us access to the quantum geometry of the structure of the universe, because we know that ultimately the universe has a lot of empty space in it, and that's represented by irrational numbers.